Hi, everyone. Welcome back to PyData Global. We're excited to have you join us for the next session. Feel free to use the chat to connect with fellow attendees and share your thoughts during the session. But now it's my pleasure to introduce Patrick Deziel. He'll be presenting his talk, Putting the Data Science Back into LLM Evolution. Patrick is a Python and Go developer and machine learning specialist and currently works at Rotational Labs. Let's all give a warm welcome to Patrick.
Thank you. It's good to be here. So my name is Patrick. I'm a distributed systems engineer and machine learning specialist at Rotational Labs. So I'm based in Minnesota. So if you're not from the States, that's where that is on the map there. I spend most of my day job doing building custom AI ML solutions for clients. So I'm using a lot of Python and Go. Like to do a bit of rock climbing for my free time. So let's be discussing the risks of LLM-based applications and the current problems with evaluating those applications, and then I'm going to talk about how to shift the mindset to evaluating LLMs with data science, and then I'll briefly discuss an open source tool that we've developed for doing LLM evaluation. So I want to start by talking about chatbots. When I think about chatbots, my mind goes to the Microsoft Office Assistant, which I would immediately close because I found it intrusive and unhelpful. And I think there's kind of a modern version of that, or that carries the same resentment, which is like if you are interacting with a chatbot that you think should be intelligent, but it ends up getting some basic things wrong. So I think that is one downside, is that this kind of presumed intelligence, but getting basic things wrong. So another risk I would say is that's pretty important is security in LLMs. And so one example of this is information leakage. So an example that actually happened with us is that we had fine-tuned a model from documentation, which mentioned company names a lot. And then when we actually tried to use it for inference, it ended up just producing company names where we didn't want them to appear, which is obviously not something that we wanted. We didn't want it to divulge the information. So that's one risk of using some of these text generation models. Another risk is prompt injection. So if you have a malicious user, they could potentially abuse your system for unintended ways. The funny example is like printing out a cooking recipe. A more serious example might be getting the LM to divulge information about like internal systems or proprietary information, which you don't want the LM to be producing. And finally, there's a reputational risk, right? So the more, so even like at larger companies, very specific edge cases and errors can cause bad user experiences, can decrease the buy-in to these types of applications because it decreases like the user confidence and in using this type of technology. So there are a few recent examples of this, of either like these systems crashing out or producing um, bad or unsafe outputs. So there is a reputational risk to introducing this technology into these workflows. So at the end of the day, we need a way to evaluate LLMs in terms of correctness, quality, and safety. So there are current ways of doing this for foundational models. I think three different ways of evaluating LLMs. There's standardized benchmarks, which use huge prompt sets to try to determine which models are performing better at those specific prompt sets. There's a more of a human voting approach, which attempts to utilize a human opinion to determine which LLMs are producing the better output. So, an example of this is the chatbot arena, which has a bunch of LLMs, and basically, when you go onto the site, um, you don't choose which LLMs you use. You just like choose to enter a prompt, and then you get like two random models, and you select which one is better. So it's a way to introduce some type of blind preferential voting into the to determine which model that like the collective would rate as better. Um, and the other way is to use evaluator LLMs. So, like, there's been some talk about of using specialized LLM judges, which are designed to rate the responses of other LLMs. I think the jury is kind of still out on whether like that approach can be consistent enough to be reliable. But usually, as machine learning engineers and data scientists, what we're dealing with on a day-to-day basis is really the fine-tuned models. So these are like the smaller models, which we are fine-tuning for very specific use cases. And for those, usually what happens is that we end up having to do a manual evaluation, where we require very specific knowledge to rate and rank models. And additionally, the correctness ends up being highly contextual. So what is correct for one instance may not be correct for another instance. So um, in the before time, so this is like before LLMs, when we're just dealing with very what seem very simpler right now is simpler supervised machine learning approaches. Is we'd have an annotated test set, and we have a training set. So we train a model, and then we would test the model against the test set, and then produce predictions. And that gave us like a really numerical way to determine if a response was or if the model is better, because we could just look at um, F1 scores and precision recall for classification uh, um, to quantify success. The problem with language models is that since a lot of them are producing variable length text output, it becomes a lot more less straightforward to compute accuracy. So, like, if you're given the expected response and you have the actual response from the model, like, how do you actually determine if the response is good enough? Um, so, one way to do it is to use analytical methods. So you can look at perplexity, which is the measure of uncertainty for what the model is generating. So basically, it's looking at, given a previous context, how likely is it to predict the next token? And this is something that's used in when these models are being trained to get like a loss metric, but um, it's ends up being more of a measure of confidence than actual correctness, because it's really determining like how uncertain the model is at like producing human like output. So usually, like a more reasonable correctness measure is based on similarity analysis. So this is like an older kind of style technique using just text similarity with text embeddings that try to encode meaning or like semantic meaning or word frequencies, and doing the vector math to compute how close two responses are to each other. And then you could also use heuristic methods to do something similar, but in a more like kind of naive, more structured way, where it's just looking at the words in each of the responses and seeing if they overlap, if they contain the same words. So these methods don't uh, really account for factual accuracy, and or response quality. So a lot of times what we're interested is looking at what the how like actually qualifying the response. So give you an example. I asked two different models like why the sky is blue. They both give me responses which could be considered correct, right? Because they both mention the Rayleigh scattering and how our eyes are actually perceiving the blue light versus the other wavelengths of light. So um, the point here is that Model B is presenting the information in a much different way than Model A. So this is something that we'd pick up on as humans. We might prefer Model B in some instances, but also prefer Model A in other instances. Like Model A is a lot more straightforward. Model B would look better if you had like a markdown viewer. So um, so that's one instance where like the one response might be better depending on the context. So what we really need is a science based approach to evaluating these LLMs, kind of like we did in the older days of data science, but updated for the world we're in now. So what does this actually mean? It means that as data science, we know that we need to have reproducible experiments and measurable metrics. We also need evaluation sets in order to compare different models so we can say exactly like how better this model is compared to the other model. Um, we also need so for if we're dealing with LLM classifiers with like constrained outputs, this would be classifiers which are outputting like a positive or negative semantic rating or just like produce or predicting like a class label. We can still use metrics like precision recall F1 scores because that just matches like with how we're doing it previously. For text generation, it's going to be a lot, maybe a bit more complicated because we need to find custom metrics for determining how correct or how better one response is versus the other. So what I'm getting at is that it's kind of our responsibility to develop new metrics for the exact use case we're dealing with. So I have a list of potential metrics here that I've looked into for various use cases um, so this is divided into automated things that can be automated and things that cannot be automated, right? So what can be automated is relevancy. So you can check the distance using like cosine similarity or just more of a like a simplistic similarity, like Jacquard distance. Uh, you could also look at validation approaches like is the response like matching what we expect with regex or does it actually match the JSON schema we asked the model for? Is the length of the text matching what we expect the length of the text to be? Uh, and we can also look at quality in some automated way, right? We can look at uh, are the sentences starting to repeat themselves as the output continues? Is the readability like it is it something that's readable to humans? So there are actually metrics you can look at for that, such as like the Flesch Kincaid one for rating reading grade level. Uh, and you could look at styling as well. Like, do you expect the response to contain those like markdown indicators, or do you want it to be in multiple paragraphs? So that's more of like a qualitative measure, which you could determine automatically. And the last point is safety. So PI detection, and you can use a lot of Python libraries for that. The other part is more esoteric. So the manual review, you would need to look at like is the response coherence? You probably need to have a human look at that. Factual correctness is hard to determine without real having a human look at that. And then helpfulness, like is the response actually helpful to the person, to whoever is reading the response. So those are some metrics that you could look into for like bootstrapping a data science approach. For assessing human feedback, there are two ways really of doing this. One is the like dislike votes, where you just vote if a response is good or not, which you can use to train reward models for your machine for your LLMs. The other way is preferential voting, which matches the style of the chatbot arena approach, where the humans would vote which one is better, and then from there you can produce a model ranking based on like the collective opinion. So, two ways of assessing the human feedback. So, from this, here are the guidelines that I came up with for LLM evaluation. So, we need a fair comparison, right? We need to have evaluation sets with complete prompts and expected outputs in order to actually compare the results across models. We need to be able to capture useful metrics. So that means in a lot of cases defining custom metrics that actually do make sense for the use case, and we're not just um, relying on perplexity or something that doesn't really match with the intended use case. Then there's reproducibility. So making sure that your experiments that we're doing are reproducible, and capturing configuration, because there's a lot of configuration when you're doing inference, such as tokenization and generation, making sure that you're generating the same amount of tokens and things like that. Uh, and also, we need to keep in mind, um, at the end of the day, like when this is going in front of the end user, how they are going to respond to it. So this involves getting humans in the feedback loop as early as possible, so that uh, whatever we're building can meet those user expectations. They're not surprised by what we're delivering. So that gets me into Parlance. So Parlance is an open source Python tool that we developed for qualitative LLM evaluation. So the inspiration for Parlance was that we were just a bit upset at how we were dealing with how we were doing LLM evaluation, which is like a very ad hoc and very inconsistent, which made it very difficult to tell which models that were actually doing better than other models. Doing that baseline comparison is what we needed. Um, so behind Parlance, it's basically just a Django web app at its core, and the idea is that we're just doing a simple model to model comparison based on the prompts and expected output. Um, uh, Huge focus on qualitative evaluation, right? So this is actually involving um, us going onto the system and then like looking at the responses and rating them, because we found out that that was like the limiting factor for us, is like we need to be able to do that as fast as possible. So it's about making that manual evaluation as quickly as possible, and also having some numerical metrics to quantify improvement. Um, so the manual evaluation part is very inspired by Spacey's Prodigy, which is an annotation tool, which basically the idea of that is that you're only looking at one example at a time to make it as easy as quickly as possible to just annotate a data set. And we want to have the model progress as visible and understandable as possible, so that we are um, so that we can understand at every point in LLM development, like are we going in the right direction and or not. So and this parlance just relies on a few standard Python tools you may be familiar with, so Django and LLTK and scikit-learn for doing NLP analysis on the responses. So this is what a like the dashboard looks like. So here I've defined an evaluation that has like 50 prompts in it. The idea is you run the same evaluation against two different models, and then you're able to compare um, using like the apples to apples comparison which model is better. So I have two charts down there, which are a bunch of different metrics we defined. So I have similarity, which is just like cosine, similarity to the expected response. Valid output is like more useful if we're doing JSON parsing, so we can tell if the output was actually JSON parsable or not. Leak sensitive is about detecting PII in the response. Hazard repetition is a metric for determining is the output repeating itself too much, which might be undesirable for certain situations. Um, and finally, is the length in the expected range. So what it looks like as a human reviewer, because we want it like human review is very important to this. We want to make sure that everybody can get onto this dashboard and then look at what the actual responses look like versus like something like a Python notebook. Uh, so what this looks like is that you have the prompt, you can see the full prompt as it's being sent, as it would be sent into the model, and then the expected output, and then the actual output. So you can compare that way, um, uh, uh, and then see is the response actually kind of matching what we expected it to be. So include this as some automated metrics. So we work to like in the app to make sure that we can automate as many metrics as possible. So detecting if the text is in the right format, does it contain sensitive terms? Is it repetitive? Is the output in the expected length? And then we have a similarity threshold to automatically determine if the expected output matches the actual output. So a lot of these metrics are qualitative, like I said. So it's more of a way that we can quickly look at responses to ensure that the models are producing the types of responses that we want. And then here's another example, just with the other model, the llama model. So um, what do I want to see in the future of LLM evaluation? I want a way to easily experiment with different prompting styles and techniques. So, uh, prompt, engineering is pretty important to developing these models because they will vary. Their outputs will vary a lot depending on the exact prompts that get sent in, and like the way that information is presented in the prompt turns out to be like a huge factor. So I want to be a way to be able to experiment with that at kind of like like an easier level than just working in like a Python notebook. Um, I also want to be able to capture human feedback in a useful way. So using a blind preferential voting scheme like Chatbot Arena would be great because it will allow us to kind of solicit a collective opinion from a group like your development group versus like the people you're delivering the model to. Having like a stakeholder dashboard which actually shows like the progress bar for like how much data do we need to be able to train this model, and then a quick glance at like how the current models are performing, so we have some accountability from our side of the models that we're actually building to make sure that the responses are in line with what the user and the end users are expecting. And finally, last point is about security. We think that having an actual permissions model, like somewhat in the way that you would manage permissions on like a Linux file system, would be great for generative AI, because it means that we could better control like what different things we're using for inference versus training, what's available if you, for example, do like a RAG request where you're retrieving information from external sources. Like, how do you protect that information from getting into like the LLM output? So there's a good blog post about that my colleague Benjamin Bankford wrote on our blog, so you should check that out if that interests you. Um, so I think with that, we reached the end of my talk. So thanks for listening. We might have a few minutes for questions here.
I do see a question, and I'll put it on the stage here. Can you talk more about the feedback loop between Parlance and your notebook environment? Is there an API to upload prompts for human evaluation and download the results?
Yeah, exactly. That's a good question. So right now there's a way that you can basically right now I have to write custom code to output the evaluations from the dev environment where I'm kind of testing with the different prompts or doing the actual evaluations into like JSON files, and then we have a utility for uploading those into the app. But that's something that I would be interested in improving. Parlance is like making that workflow as easy as possible, because otherwise it takes like a long time to like to you're constantly like moving files back and forth. So we want to make that easier. Great question.
Yes, thanks, Keith. Are there any other questions? So we have about another minute or two. Yes, we have one. Does the blog post already provide an active implementation of data access controls, or just frames this as a problem?
Yeah, good question. There's not an implementation we have currently, but so it's mainly just an idea as it exists right now that we're interested in hearing if people have already tried implementing, or if they have comments on it. So
Another question. Say I give a chatbot a gotcha question, like, tell me about the results from Abraham Lincoln executing Jefferson Davis for treason. The right answer is no, he did not. A lot of bots will make up something fabulous but false. How would you check?
right. So I think that leads into the importance of human evaluation responses, because I think it's hard for automated methods to really detect that right now. So um, I guess the way that we're proposing is getting humans in the loop uh, as early as possible, so that we can detect those things a lot more easily.
Yeah, so I think with that we are at time. So yeah, let's wrap up. So Patrick, thanks for presenting today. This is great, and thanks for everyone for tuning in. And if you'd like to continue the discussion, you can head over to the Discord. Link is in the reception area. And otherwise, hope everyone has a great day. Let's give Patrick a round of applause.